So here we need to find out the value of the given expression. Here h1, h2 all the way up to hn are n harmonic means that has been inserted between a and b. So let us begin. Now since n harmonic means are inserted between a and b, so this means that a, if we consider the first term to be a followed by the next term which is h1, then we have h2 going all the way up to the nth term, and then we have one final term which is b. Then this entire sequence is going to be a harmonic progression. Now if it is an harmonic progression, then we can take the reciprocal of each of the terms, and the new sequence which is 1 over a, then we have 1 over h1 followed by 1 over h2 going all the way up to 1 over hn and then 1 over b. So this sequence is going to be an arithmetic progression. Now if that's an arithmetic progression, then it's going to have a common difference. So we'll suppose that let the common difference be denoted by the letter d in uppercase. Now we'll have to find out an expression for d. So what we'll do, since it's an arithmetic progression, we will use the nth term of an arithmetic progression. So we know that the nth term of any arithmetic progression is given by an equals to a plus n minus 1 times some common difference d. Now in a case here we have the value of an. So here an is the last term, so that's 1 over b. A is the first term with the value 1 over a. So let's call it a1 so that it does not create any confusion. So a1 will be the first term with a value 1 over a. Now n in this case is not actually, let's call it n1. So n1, which is the number of terms in the arithmetic progression, so that's not exactly n, because we have n terms introduced between a and b. So in total there are actually 12 n plus 2 terms present in the entire sequence. So we can find out the value. So an will be 1 over b. So this implies 1 over b equals to 1 over a plus, so in place of n1 we have n plus 2 minus 1 times the common difference d. So let's try to find out an expression for d. The d is going to be equals to a minus b divided by n plus 1 times ab. So we're going to label this as number 1. Now that we have the common difference, let's try to figure out what's the value of 1 over h1. So that's the second term. So second term of the arithmetic progression. So all we have to do is take the previous term, which is the first term 1 over a, and add the common difference d to it. So that means we'll substitute the value of d with a minus b divided by n plus 1 times ab. Let's combine them. So we have ab multiplied to n plus 1. This is going to be the common denominator, and here in the numerator the first term, that's going to be b times n plus 1 plus a minus b. So here after simplification in the numerator we'll be left with bn plus a divided by ab multiplied to n plus 1. So this is the value of 1 over h1. Now let's take the reciprocal. Our reciprocal is going to give us h1 equals to ab times n plus 1 divided by a plus bn. Now we're going to divide both sides with a. So we have h1 over a, so that will be equals to b times n plus 1 divided by a plus bn. The reason why we wrote in this fashion h1 over a, because here we're going to use the method known as the componendo and dividendo method. So let me specify what does it mean. So let's say if we have the ratio a over b, and this ratio is equals to another ratio c over d, then the componendo and dividendo tells us that we can do a plus b divided by a minus b, and this ratio is going to be equals to c plus d over c minus d. So applying the componendo dividendo method, we will have h1 plus a divided by h1 minus a. This will be equals to, so we have bn plus b added to a plus bn divided by bn plus b minus a minus bn. So we have h1 plus a divided by h1 minus a. That will be equals to 2bn plus a plus b divided by, so here bn and negative bn cancels out. We are left with b minus a. Fine. So we'll keep it aside. Let's label this as equation number 2. We'll come back to this in a moment because this is the expression that we need. Okay, so since we have the common difference, we can define 1 over h1 for the arithmetic progression. So 1 over h1, we have already found this out. So this was the previous term, which is the first term, 1 over a, and we add the common difference d to it, and this is going to give us 1 over h1. Similarly, we can find out the third term, which is 1 over h2. All we have to do is take the previous term, which is 1 over h1, and to it we are going to add the common difference d. So that means we get 1 over a plus 2d. So if we continue the trend, then we can easily find out 1 over hn. So that's going to be 1 over a plus n times d. We have the value of d, so let's replace the value of d with, we have n times a minus b divided by n plus 1 times ab. So this is the value of 1 over hn. So what we'll do, we'll try to combine the two terms on the right hand side. So that's going to give us, so we'll have a common denominator, so that's ab multiplied to n plus 1. Then in the numerator we have b times n plus 1 plus n times a minus b. So this will be equals to bn plus b plus an minus nb divided by ab multiplied to n plus 1. So here bn and nb gets cancelled out, and we are left with b plus an divided by ab multiplied to n plus 1. So this is the value of 1 over hn. But what we'll do, we'll take the reciprocal on both sides, so that gives us the value of hn. So that will be ab multiplied to n plus 1 divided by b plus an. Let's divide both sides with b. So we have hn over b. So that will be equals to a times n plus 1 divided by b plus an. We will be applying the componendo dividendo on both sides. So we have hn plus b divided by hn minus b. So this will be equals to, so we have a times n plus a added to b plus a in the denominator divided by, we have an plus a minus b minus an. Right, so what that gives us, hn plus b divided by hn minus b. This will be equals to 2 times an plus a plus b divided by, so an and negative an goes away, so we have a minus b. Fine. So now we're going to label this as number 3. So here we have obtained the value of h1 plus a divided by h1 minus a as given in equation number 3, so or 2. So what we'll do, we'll add 2 and 3. So we're going to add equation number 2 with equation number 3. So we get, on the left hand side we have h1 plus a divided by h1 minus a, plus we have hn plus b divided by hn minus b. This will be equals to 2bn plus a plus b divided by b minus a. So let's do one thing. So we will multiply the denominator with negative 1. So we'll have to multiply the numerator with negative as well. So we have negative times 2an plus a plus b divided by a. And this will become b minus a. And this is done so that we can easily combine the denominator. We have a common denominator of b minus a. Now in the numerator we have 2bn plus a plus b. Then we have negative 2an, negative a, and negative b. So here we can cancel out positive a, positive b, and negative b. And then we are left with 2bn minus 2an divided by b minus a. If we factor out 2n, so in the numerator we have 2n multiplied to b minus a divided by b minus a. Now we can factor out b minus a from the numerator and the denominator. This is going to leave us with 2n, and we have successfully showed that. So let's write it down. Therefore h1 plus a divided by h1 minus a plus hn plus b divided by hn minus b. So this is going to be equals to 2 times n. So this is what we are asked to prove, hence proved.